Hi there, and a very warm welcome to this week's video, which is the third part of our Plasticity series in which we finally are exporting. But before that, I made a couple of oopsies, so we are going to fix them, and also we are going to round, bevel, fillet, or whatever name you call it, the model of our watch. So without further ado, let's grab your coffee and let's jump right in. Welcome to the What's Up section. Basically, what I did this week is to prepare this watch model for shading and then also rendering, as you can see in the background, and also animation. I had the feeling that people didn't really get where this tutorial series is going, so I made this to give you some incentive to watch and work along with this series. This week is a very long video, as this is basically made into 3 parts. First, we are fixing some things. Second, we are doing all of the rounding or filleting. And lastly, we are doing the export. If you just came for one of those topics, you can see the timestamps in the bottom of the video. As you can imagine, those videos take a lot of effort to produce. So if you want to help me and support me, then become a Patreon. The link is down in the description below. As an incentive, you get free access to all the scenes I use in my tutorials, no matter what tier you subscribe to. And now, let's jump right in ironing out those oopsies. And welcome back to Plasticity land, where the plan is to round off all of those parts and then export them. And this is our task for today. Before we do that though, last week I made a couple of oopsies that we are going to fix here. One of them, if we look at the lower part of the watch case, is that we managed to get a gap in here. I'm still not sure how this happened, but this is very easily fixed. Of course, we have seen the procedure before, so I'm going to select the face here, draw it out, and by holding Ctrl, we can snap it to the case back. Then enter to confirm and mask for the win, because the circular shape of the back is retained. Now the next oopsie I made comes from the R here, and this is best seen in another material mode. So if we go to this mode and turn off the edges, you can see we have some not straight surfaces here, so they are not curving quite correctly. If you can remember, last time we just grabbed the surface and dragged it out, so grab and drag, something like this. Somehow this creates those artifacts, so we need to fix those. Let's turn back on those edges and go into the normal material again and cancel that. Actually, what I'm proposing here is doing that all again. So what I'm going to do is select the face and move it inward until it disappears and then hit enter, so we lose our R here. Now we still have our R curves, but they are in a different location since we moved the ground to the y-axis to model it there. To find the measurement that we need, let's grab the ground, hit G, and then on the z-axis, snap it to the y-axis while holding Ctrl and then read 8.2. This is all we need. Hit escape, then select the R, grab Z, 8.2, enter, and we are good. While the R is still selected, shift select the ground and then hit Shift I to get the imprint. Enter to confirm, and then we can turn off the R again. Now we are back to square one. If you know a better way to do this, let me know, because the only way I got this is by manually creating that. So instead of moving it out, what we do this time is hit Shift D to create a sheet and then move the sheet 2 mm to the front. Here we go. Of course, we somehow want to connect it to the ground, so we need to select the R face here too and then delete it by Shift Xing. Now the next operations are best done in pure edge mode, so hit 2 or click that. Then what we want to do is select both outer edges here. By holding down Alt, you can select them, Shift Alt for the other edge, and then what we can do is hit L for loft. Right now it has a G1 interpolation, we don't want that, we want it to be linear, so G0 or tab 2 times, hit enter to create it. We need to do the same thing for the inner portion, so deselect all, Alt and click for this edge, Shift Alt click for the other edge, then L, then tab enter. Here we go. Now as you can see, our ground is made up of individual sheets. We don't want that. So of course we can select them all by shift selecting them and then in the viewport hit J for join. and this gets us back our ground solid. And now if we change the shader model again and hide the edges and then move around with our camera, you can see now we have a pristine, not edgy area here. Editing Raphael from the future here, so I missed one important aspect that should be mentioned. If you're finished with your model except the rounding step, it's a good practice to save it as an extra file, because the rounding might not be easily undone later. So if you, for example, want to do a remeshing or returbo version of the watch later, it's the best if you have the harsh edges saved. Because remeshing, for example, works better with hard-edged models because the edge can be detected much more easily. So save your model as final unrounded and then continue with the tutorial. While we are at it, let's begin this rounding process with our crown here. So let's hit the dot for soloing that. And then let's start with the R on the front. We are going inside for that for some reason, which will be clear in a second. Like last time, we're going to round those outer edges. For this, let's go into edge mode and select the outer edges here, like this. And then we are going to bevel or fillet them by B, which is the fillet command, and then D, which is the distance, 0.2, enter, enter. While we are at it, other than last time, let's select those inner edges too and make them a little bit more shallow. So BD and then 0.1. Here we go. Alright, so let's go outside and touch some R. Not sure if that's appropriate, but let's do it anyway. Let's select all of the 4 edges of the R by holding down Alt for the first edge and then Shift for the consecutive edges. Here we go. If we now repeat the command strings, BD 0.05 for example, that works. We can hit backspace and type in other numbers, so backspace 9 for example, and you can see 9 isn't working. Is 8 working? No. Is 7 working? 7 is the last number working. Now, since the crown is a little bit of a prestige object on a watch, I want to make the outer bevel a little bit larger, which isn't possible right now. So what I'm going to do is cancel this out by hitting Escape and then just reselect the outer ones. So here we go. Then beveling those first. By the way, by loop selecting, you have noticed that this works rather well, and this is due to the bevels that we did in the inside before. Now you know. While those are still selected, BD, and then what we're going with 0.09, and this now works because it's not intersecting with the inner edge. Hit enter to confirm. Again with Alt, select the inner both edges here, and then what we're going to do is BD. Now if we go with 0.07, you can see it still works because the outer edge is already existing. We could go even 0.09. This is too large for my taste, but it is possible. So let's go with 0.07, hit enter and enter again. And now this is our R rounded and our crown almost done. Almost done because there's not a lot more edges to go. So first of all, let's select the frontmost edge here and then Alt Shift select the serration edges, this and then go BD 0.075. Then I want to make this front edge here BD 0.05. Here we go as well. And then turn around and select the last remaining edges. Now, looking at this, I think it's the perfect opportunity to learn a little bit more about fillets. Because we are not only here to finish our watch model, but of course also to learn plasticity. Let's go with a fillet of 0.1 here, so BD 0.1 millimeters. And you can see there's something strange happening. So we have larger and smaller fillets. And this is because a circle with the radius of 0.1 right now is taken to blend between both of those sides we are beveling or filleting. And of course, if we have a more shallow angle, less of the circle is used. Now, this all is mathematically correct, which is the best type of correct, but sometimes there's a conflict between math and optics. So to make it more appealing optically, there's another method. This was shown to me by Christian Krajewski, shout out to him, a patron of mine, which is the chordal option here. So if we click that, then those edges are optically the same. So what this is doing is making the distance between the newly created edges 1 millimeter apart. So let's say we still want to go with the conic method, but then deselect this edge here What you can do is hit Control, that temporarily undoes the fillet command, and then deselect this edge, for example, and if you let go Control, then this edge no longer has a bevel. You of course can also add edges this way. Now finally, let's apply, then select this edge again. We are still in fillet learn mode, so let's say you have made a much too large fillet and already executed. To get rid of it, what we can do is go to face mode, select it again and hit delete. This also goes for more complicated fillets like this, and we can go back to its original state. Let's hit Ctrl Z to go back, because we are not done yet. As you can see, we also have a tool to change the diameter and also can type in the value, but the value comes in from the original position that we had, not from the original circle diameter. By the way, another method to get rid of it is to drag it out of its existence like this. Let's hit escape to get back to our fillet, select the face again. To be really mathematically accurate with the values of our circle that we typed in, we can invoke, and if you have seen the rest of the series, you probably already guessed it, hit F and then go with our dimension tool. And now you can see the original dimensions, so if we type in 1, we have a original dimension of 1 millimeter, that is, of course. Now let's hit enter, and this ends our training session for fillets and also the beveling process of our crown. Okay, let's go out of isolation and do some easy parts before we do all the hard ones. Let's go into object mode, select the glass and hit dot on the keyboard to solo it. Now, since the glass is a transparent element that shares its borders with the bezel without air gap in between, this would lead to set fighting and artifacts in rendering. So what I'm going to do is to offset the glass edge here in face mode very slightly. Let's hit D minus 0.01. Let's go into edge mode by hitting 2 on your number row, select both of those edges, and if they are not selecting all the way around, again hit Alt and then Shift Alt, then go BD, and this time 0.2, since glass elements always look a little bit better with a larger fillet. Enter, here we go, we are finished with our glass element. Next, in object mode again, because I want to show you something, let's select the case back, the bezel, as well as the inner case back. Of course, hitting dot on the keyboard to solo. And now if we want to select the edges of all of our selected objects, what we can do is go to the edge mode and control click on it. Of course, this also works with face to edges and so on. So with this now selected, BD 0.1, enter, enter, easy as that. The last of those easy ones is the watch face, so let's select this one here and then hold down Control and edges again, then BD, and this time 0.075. As you probably noticed from me dancing around it, the watch case is actually the hardest part of filleting. But before we do that, in the name of learning, there's something on the case back we have to talk about. So again, dot for solo, and then we want to go to one of those cutouts that are aligning with one of the axes here. Let's just turn it around, something like that. And you can see we have some problems on those bevels. Of course, you can say this is such a small detail, but it lets us introduce new tools, so here we are. Let's move a little bit closer and go into edge mode. The tool we are going to use most is the cutter tool, which in cat speak is meow. Sorry, I had to make this joke. In cat speak, this is the Isoparam tool, and we can evoke it with Ctrl R. And you can see now we can cut along the face here. If we hit tab, we can cut along the other way. So let's make our first cut alongside this edge here, like this. Okay, let's keep going a couple of times. Ctrl R here, make sure it snaps to the right position. Sometimes it's a little bit finicky. Ctrl R and continue this edge. So we have to hit tab. Sometimes holding down Shift helps to keep it on the right side. Next, let's cut this all the way through. So Ctrl R again. Sometimes cuts are rather finicky. You have to try it a couple of times. Also, the perspective sometimes matters. Also, let's extend this line here. Ctrl R, tab. And here is another example where Shift is needed. So Shift and then click. All right, I think we have everything we need. So what we need to do now is just delete out those faces here. Like this, and then hit Shift X. What we are going to do is lofting and patching this surface together. So let's go into edge mode and create our first loft. Hit L for loft, make sure it's G1, OK. You can see this is creating an extra sheet, so select both and hit J to join them. Then loft between those both parts. Again, select both of those and join. Then what we can do is alt select the edge here, and instead of a loft, we are going with a patch this time, so Shift J. This is showing G0, which means it's not interpolated, so we have a rough edge here. This is not what we want. We definitely want to have G1. OK. And this looks a lot better now. Though we have one problem remaining, this should be a solid, but it isn't. And since everything looks great here, I think it's on the left side of this edge. So let's follow this and see what's up there. And yes, you can see we have some interlocking parts. Let's fix this by going to face mode, select the face, Alt Xing this one here, then go into edge mode and with Alt select the whole boundary. And then instead of a loft, going with a patch, so Shift J, and we are going to make sure to get with G1. OK. And as you can see, we have our solid back. Very nice. Of course, we are going to work hard, not smart. It's the other way around. Maybe this is true for me, but anyways, we are going to cut out this piece, then mirror it so the patch is on the other side as well, and then radial array it around so it lands on all of the other cutouts. To do this, let's go into top view, so number pad 7. Now what we need to do is get some lines going. To make the radial array work later, we need basically a pizza slice with a 60-degree angle. So to do that, we are going to drag out a line from the middle. The end doesn't matter here. Hit enter to make it real. Let's rotate it 30 degrees to one side, so hit R for rotation. Then hit V to pivot the rotation angle to the middle here, and then rotate it finally 30 degrees. Now what we can do is mirror this over to the other side by holding down Alt X and then mirror it to this way. Enter, then select both of those in line mode, then join them, and then in object mode, select the main object and cut them by hitting C. Enter. Now let's first mirror our patch to the other side by selecting the object, then Alt X. I noticed this, so you have to select the axis where the patch is coming from to get it to the other side. Otherwise, we are making everything undone that we worked so hard for. Excuse me, so smart for. As we don't want to have separate parts, let's union them by hitting Q and then enter, and we have back one part. Now we can delete the rest of it, then go with the original object here again into radial array, and we need to change the number here. We need to have 6 parts. OK, and now what we can do is select all of them and hit QQ to unionize them together. And another first, I'm going to call that case back. Here we go. Now let's unsolo the rest of the watch and marvel at our creation here. As I said, definitely not really necessary, but if you're a perfectionist, it's very nice to know how it's done. So let's finally tackle the last bit before the export, the watch case. I called this hard to do because obviously it's not as easy as control clicking the edge and then BD 0.1. This doesn't work. So let's escape out and look at the culprits that are responsible for this. And those are the end of the lux here. You can see what's happening here is a very narrow angle that results in that pinch. And situations like this are extremely hard to fillet. What this asks for is basically like a game. We have to find a sequence that will make it work. So again, let's go with the easy to fillet parts first. And I forgot something on the lux last time because this outer corner is really sharp. So let's BD this with a generous 0.5. Continuing with this easy to do trend, let's select all the circular uninterrupted edges, mostly in the inside of the watch, and then bevel those BD 0.1. Again, disclaimer, I already know the sequence that in the end lets us bevel everything. Just saying that in situations where this might be a stumbling block for you, there's usually a way. For me, the first step in the sequence is to alt select the outer parts here on both sides, and then also the part where the crown is attached. And although it's going over the pinch, it will allow us to go with a 0.1 bevel. Next, I'm going to show you this on one side first. So again, while holding down Alt, I want to select the inner lux, then also those both edges here, and also the upper edge. Now for the lower edge, if we hold Alt, it will continue on to the very end. But what we actually need to do is just select the edges in between both lux. And as foretold, I'm also able now to bevel this. So BD 0.1. And now if we go and look at the lower part here, you can see, although we only selected the middle edge, there's a small bevel happening here. Now, admittedly, this looks a bit shoddy, but you already have seen me clean up stuff, and I'm sparing you this time, as it's the lower side of the watch and it's a very small detail. And with that, I think we beveled everything. Oh, I just realized we didn't bevel the other side here, so with the motto of our show, work smart, not hard, I got it right this time, we are going to select the watch case, and since it's symmetrical on the x-axis, then go with Alt-X, and then just mirror it on the other side, and we are going with a union and enter. Here we go. And with all that being done, took us long enough, let's transition to the chapter most of you have been looking forward to, the export. And welcome to the export section. I hope this is not a letdown because it's remarkably simple. I'm going to show you two ways to export, one through Plasticity itself, and my personally preferred method through Moments of Inspiration, Moi3D. This is another CAD software that produces remarkably clean meshes. If you have Octane, there it is included already. Let's have a look at Plasticity first. You will find the export option here in the drop-down menu, or for convenience, Ctrl-Shift-E. So let's hit that and we are greeted with the export directory. Let's say we are good with that, and then we have some options here. And don't be shocked, this is the worst it's going to look. It's only getting better from there. But for some of you, this might be the standard look how you imagine CAD files to look inside of your 3D program. This is the standard export method and it's set to tries. And I'm guessing this is because it's the most compatible option. But if your 3D software is capable of quads or even n-gons, then we are getting a lot better results. Granted, it still looks a little bit wonky, especially in those curvature parts, but this is due to lack of resolution, and we can give it to the model easily with the edge angle tolerance. So if we make the tolerance smaller, for example 0.1 here, and then you can see it's thinking, we get a better model as the cause of that. Basically, this is your main quality slider, so let's go with 0.05, and while it's thinking, telling you about the Plasticity exporter and its disadvantages, as you can see, it's thinking quite long to generate the new resolution that we just set. Here we go. Now, while I like the overall resolution, there are two things I don't like. The glass, for example, has very little segments on its rounding, and if we zoom closer, we have way too much subdivisions on the fillets. Fortunately, there are settings for this too. And that comes in with the min and max width. So let's tackle the min width first. It looks like we're back to square one, but all this parameter tells the model is to avoid subdivisions smaller than 0.01 in this case. And this is quite large, so what we need to do is fill in a couple of zeros, so 0.00, maybe 2. Let's see if that looks good. And now you can see we keep the overall density of the mesh, but in the beveled areas have less resolution. Maybe still too little, so let's try 0.001. I think 0.00005 here is the right value to go with. Remember, our watch is very small, so we need small values, and this looks quite nice overall. With max width, we have the other side of the spectrum. Basically, you can think about what this is doing. It's telling the program to subdivide areas that are larger than a certain value. So let's type in 0.002, for example, and you can see now we have diced the subject into smaller chunks, including, and this is what we wanted, the roundness of our glass here. Now, the last thing before we jump into Moi3D, The look of the glass and the bezel is now pristine, but we have some weirdness going on in the watch case. So if we cancel out the export for a second, what you can do is select the glass and the bezel and then go with Ctrl-Shift-E for export. Let's say we want to have this name, then we can export this part of the mesh with those settings. Then what we can do is select the rest of the watch and export that with different kinds of settings. For example, turning off the max width here. Small tip on the side, I always screenshot my export settings and document them, so I know what I exported with what settings. This makes me think that renameable presets here would be nice, maybe something for a future Plasticity build. Now, since Moi3D is another CAD program, but Plasticity files are proprietary, we need to export into a CAD file. This is also rather easy, so Ctrl-Shift-E again, and instead of OBJ, we are going to go with a step file. Basically the OBJ of the computer-aided design world. Let's hit save here, and we also have a dialog. There are different step versions. I was always lucky going with the first one that's already preset, the AP203, so let's do this. And now we can switch to Moi. Small interlude, let's cherish this moment of inspiration, pun intended, and talk about Moi3D. Moi is another purchasable computer-aided design software. Granted, it is on the pricey side, especially if you're just using it for export purposes. Though I'm bringing this up because if you have an active Octane subscription, it is included in there. So if you're going to your Octane profile under Applications and scroll down here, keep an eye out for Moi3D. Now I will say following, the Plasticity exporter is a big step up from all the other exporters I had in CAD programs before. So you're probably fine with this. If you want to go for the extra 10%, then use Moi. And welcome to Moiland. If you're thinking, this is a 3D software that comes with Octane, so why are we using Plasticity and not this? While it would be possible to do all this in here, I find Plasticity way more intuitive. I've seen people do amazing things with Moi, it's just not for me, I have the feeling. So I'm using it as a glorified exporter. Let's go on and just drag in our exported Watch 2 step file and wait for a second. And here it is, our watch model in all its glory. Let's switch to Holy 3D view here and then go straight to export by hitting save. It's roughly the same as in Plasticity, but we have more options here. So what we want to do here is convert into a mesh, so we can either go with Wavefront OBJ or FBX. I had occasions, especially with bigger models, where OBJ wasn't working, so I tend to go with FBX here. Let's copy in its name and hit save. And this gives us the export dialog, which is very similar to Plasticity as well. So again, we can set our base mesh density by using this number or the slider here above. It just gives us a number down here. Also, you can see that Moi is a little bit faster than Plasticity in generating those meshes. Then again, to get the density down on those bevels, we can avoid smaller than. Let's go with 0.05 for example. Probably 0.1 is enough, as we still have quite a lot of subdivisions here. So let's go with 0.1. That looks better. Then we go with divide larger than. Let's see if a value of 0.75 is good. This might be a little bit too dense, so let's go with 1.5. This looks just nice. What I really like about Moi compared to Plasticity, we don't get any crooked edges here, and also areas that have no curvature are left alone by the subdivision. If you really need these subdivisions because, for example, you're deforming your object later in 3D, then there's an option for this, but generally it's good to get this only on curvature because it saves us from a lot of polygons. Now, disclaimer, this is still just a cut export and not a quad mesh. We are dealing with a lot of n-gons here, for example here, or this mismatch here. As always, stuff has the potential to be better, but still this is the best export process I have found yet. And even though there are mismatches, it will be interpreted by your 3D program due to the normals quite nicely. I made a video especially on the normal handling and import in the upper right corner if you're interested. To finish up this session, all we have to do is press OK. And next time we are importing and starting the shading process, finally. On screen, as in the beginning, you can see the outcome that our watch model will have once it's finally shaded and rendered. I really hope you liked this part of our series. A lot of work has gone into it. If you want to support this channel and what I'm doing, consider becoming a Patreon as incentive. You can download all the scenes I use in my tutorials, no matter what tier you subscribe to. And this ends this week's chapter. Thank you for watching till now. Let's thank those people who made this video possible, my patrons. Especially my €50 tier subscribers, Shields Augustinen and Leon Studio TV. Also, of course, a huge thank you for my €15 tier subscribers, Doijim. For the Thieves, Render King, Alessandro Bonchio, Alessio De Vecchi, Ami Schietried, BVR, Christian Grajewski, Erbe Plus Academy, Joel Mackimer, John Edward, Chris Clemson, Ness Graphics, Nico Straub, Part 1 of 2, Ralf, Reiko, Reshock, Shamus Johnson, Shiro 2049, Terry Wayne Ranson, and Yassin Rupp. And welcome to our little after-show party. This time a extra big thanks and show of gratitude for sticking with that very long video. As almost always, it's late here again, so it's 1:05 AM. This time I actually started on Saturday morning because I thought I could outrun the time, but somehow it doesn't work, as I'm getting more time in and it's always getting late. So hopefully you at least like the video. With this video I'm making a small experiment since the last video I released in the middle of the night, 3 AM or something. It tanked because the algorithm didn't pick it up. So this time I'm releasing it on Patreon once it's finished and at 9 o'clock in the morning German time on YouTube. Hopefully it will be distributed better this time then. Again, if you want to help me against the algorithm overlords, then post a cat. I know the spelling is T versus D, but close enough. And with that, thank you again, a good start into this week, or if you're watching this later, a great time around. And I say, happy exporting. Meow.